Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle and inside this circle we have quadrilateral ABCD. We know that side AB of quadrilateral ABCD equals to 3 units. So we will define side AB as A, and we know that A equals to 3 units, and we also know that side BC of quadrilateral ABCD equals to 4 units. So we'll define side BC as B, and we know that B equals to 4 units, and we also know that side DC of quadrilateral ABCD equals to 5 units. We will define side DC as C, and C equals to 5 units, and we also know that side AD of quadrilateral ABCD equals to 6 units, so we will define side AD as D, and we know that D equals to 6 units. And we want to find out the radius of this circle. Again, quadrilateral ABCD is inscribed in this circle or by this circle, and we want to find out the radius of this circle. Okay, so I will present to you three new rules, and we will implement the three rules that I will present to you in our drawing. So the first rule number 1, will be that the area of a quadrilateral that it is inscribed in a circle, the area of a quadrilateral that it is inscribed in a circle equals to actually this is the sign of area, so the area of quadrilateral ABCD. So here we have a circle, and inside this circle we have a quadrilateral. So So this quadrilateral is quadrilateral ABCD like in our original drawing. And side AB of this quadrilateral equals to A units, side BC equals to B units, side CD of quadrilateral ABCD equals to C units, and side AD of quadrilateral ABCD equals to D units in its sides. So the area of this quadrilateral that is inscribed in this circle will be equal to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of this quadrilateral. The length of side AB is A, the length of side BC is B, the length of side CD is C, and the length of side AD of quadrilateral ABCD is D units. So, and S in this equality equals to the sum of the quadrilateral sides, that is to say to A plus B plus C plus D over 2. Okay, so I will repeat on rule number 1 again. According to rule number 1, the area of a quadrilateral that it is inscribed in a circle equals to, this is the sign of area, the area of this quadrilateral ABCD that it is inscribed in this circle equals to the root of S minus A times S minus B times S minus C times S minus D. In this equality, A, B, C, and D are the lengths of this quadrilateral. Side AB equals to A units, BC equals to B units, CD equals to C units, and AD equals to D units, and S equals to A plus B plus C plus D over 2. Okay, so if you have a quadrilateral that it is inscribed in a circle or inscribed by a circle, then you can calculate the area of that quadrilateral according to this formula. And so that is rule number 1. In the next step I will present to you rule number 2. Rule number 2 states that if a quadrilateral is inscribed in a circle, if a quadrilateral is inscribed in a circle, Then the product of its diagonals equals to the sum of products of its opposite sides. So I read rule number 2 again. Rule number 2 states that if a quadrilateral is inscribed in a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and a quadrilateral is inscribed in this circle, we have quadrilateral ABCD that is inscribed by this circle or in this circle. And the size of side AB is A units, the size of side BC is B units, the size of side CD is equals to C units, and the size of side AD of quadrilateral ABCD is D units. And we also know that diagonal AC of quadrilateral ABCD, diagonal AC of quadrilateral ABC equals to X units in its size of the size of AC equals to X units, and the size of diagonal BD is actually Y units. PD equals to Y units in its size. Then, according to rule number 2, the product of its size, if we have quadrilateral ABCD that is inscribed in a circle like in this drawing, then the product of its diagonals, that is to say x times y is the product of these quadrilateral diagonals. So the product of its quadrilateral diagonals equals to the sum of the products of its opposite sides. So we have here side BC is opposite to side AD, and the product of those two opposite sides is B times D. And we also have a second pair of of opposite sides. Side AB is opposite to side CD, and the product of those two opposite sides is A times C. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of product of its opposite sides. The first product is BD, the second product is AC, and the sum of the product of the opposite sides is BD plus AC. So according to rule number 2, the product of a quadrilateral that is inscribed in a circle, the product of its diagonals, that is to say x times y, equals to the sum of the product of its opposite sides, and the sum of the product of its opposite sides is BD plus AC. So again, if we have a quadrilateral that is inscribed in a circle like in this drawing, then the product of the diagonals, the product of the quadrilateral diagonals is x times y, and this product equals to the sum of the product of its opposite sides. The sum of the product of the first product is B times D, and the second product is A times C, and the sum of those two products of the opposite sides is BD plus AC. So x times y, the product of the quadrilaterals diagonals, that is x times y, equals to the sum of the product of its opposite sides, that is actually BD plus AC. Okay? So if you have a quadrilateral that is inscribed in a circle, then the product of its diagonals, that is to say x times y, equals to the sum of the product, to the sum of the products of its opposite sides, and the sum of the product of these quadrilateral sides is BD plus AC, that is to say xy equals to BD plus AC according to rule number 2. Okay? Again, if a quadrilateral is inscribed in a circle, then the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. That is to say x times y equals to BD plus AC. Okay, that is rule number 2. And we also have rule number 3. Rule number 3 states that if a triangle is inscribed in a circle, if a triangle is inscribed in a circle, then the radius of that circle equals to the product of that triangle sides over 4 times the area of that triangle. So I'll read rule number 3 again. Rule number 3 states that if a triangle is inscribed in a circle, then the radius of that circle equals to the product of that triangle's sides over 4 times the area of that triangle. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have a triangle that is inscribed in a circle, for example, we have a triangle ABC, this triangle ABC is inscribed in this circle. We know that side AB of this triangle ABC equals to A units in its size. Side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. Then, according to rule number 3, the radius of this circle that blocks this triangle ABC will be equal to the product of triangle ABC sides, that is to say to A plus B, A times B times C. Again, the radius of this circle that blocks triangle ABC will be equal to the product of these triangles sides, that is to say to A times B times C over 4 times the area of triangle ABC, over 4 times the area of triangle ABC. So this sign means the area of triangle ABC. Again, if you have a triangle that is inscribed in a circle, then the radius of the circle that blocks the triangle that it is inscribed in a circle will be equal to the product of that triangle sides, that is to say to A times B times C over 4 times the area of the triangle, over 4 times the area of this triangle ABC. Okay, so the meaning of rule number 3 is that if you have a triangle that is inscribed in a circle, then you can know the radius of that circle that blocks the triangle only by knowing the triangle's sides, the lengths. If you know the lengths of that triangle's sides, then you can calculate the radius of the circle that blocks that triangle. Okay, you also will have to actually to calculate uh, the area of the triangle, but when you have all the sizes of all the three sides of a triangle, it is very easy to find out the area of the triangle. So actually, if you have the length of the three sides of the triangle, then you will know the radius of the circle that blocks that triangle. Okay, so uh, we will implement all the three rules that I presented to you in our drawing. So actually, this is our original drawing. We will draw two diagonals of this quadrilateral ABCD. The first diagonal will be diagonal BD, and we define the size of BD as x, that is to say x, the BD equals to x units, and we will draw the second diagonal of quadrilateral ABCD, that is actually AC, and we will define the size of AC as y, that is to say AC equals to y units, while BD equals to x units, and we will implement all of the three rules that I presented to you in our drawing. According to rule number 1, the area of this quadrilateral ABCD, I will repeat again that is the sign of area of quadrilateral ABCD. So the area of quadrilateral ABCD equals to, according to rule number 1, to the root of s minus a minus times s minus b times s minus c times s minus d. That is the area of our quadrilateral ABCD when A, B, C, and D are the lengths of these quadrilateral sides, and S equals to, according to rule number 1, to the sum of its sides, that is to say to A plus B plus C plus D over 2. Okay, that is actually the implementation of rule number 1 in our drawing. So that is the equation number 1 is the area of this quadrilateral ABCD. Okay, S equals to the sum of quadrilateral ABC sides over 2. And then we will also implement rule number 2 in our drawing. According to rule number 2, if you have quadrilateral that is inscribed in a circle, like in this drawing, then the product of its diagonals, that is to say x times y, equals to the sum of the product, to the sum of the products of its opposite sides. That is to say, it equals to BD plus AC. BD plus AC. Okay. XY equals to BD plus AC So equation number 2, it is actually the implementation of rule number 2 in our drawing. And actually we have also rule number 3. If we focus on triangle ABC, this triangle, according to rule number 3, the radius of this circle that blocks triangle ABC, or triangle ABC is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle, that is to say capital R, the radius of this circle, equals to triangles ABC, the product of triangles ABC sides, that is to say A times B times Y, over 4 times the area of triangle ABC. So actually equation number 3 is the implementation of rule number 3 in our drawing. We have, if we focus on triangle ABC is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC equals to the product of triangles ABC sides, that is to say to A times B times Y, over 4 times the area of triangle ABC, over 4 times the area of triangle ABC. Okay, so the radius of the circle that blocks triangle ABC equals to the product of triangle ABC sides, that is to say A times B times Y, over 4 times the area of triangle ABC, according to rule number 3. Okay, so here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC equals to A times B times Y over 4. So we multiply the equation number 3 by the area of triangle ABC, and we got this equality. Here we will divide the equation number 3 by R, and we will get that the area of triangle ABC equals to ABY over 4R. I will repeat again. We divided this equation number 3 by R, and we got that the area of triangle ABC equals to ABY over 4R. Okay? In the next step, we will focus on triangle ADC. So, in triangle ADC, actually triangle ADC is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle that blocks this triangle ADC will be equal to the product of triangles ADC sides, that is to say to C times D times Y, over 4 times the area of triangle ADC. Okay? I will repeat again. This triangle ADC is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangles ADC sides, that is to say, it will be equal to C times D times Y, over 4 times the area of triangle ADC. Over 4 times the area of triangle ADC. Here we will multiply equation number 4 by the area of triangle ADC, and we will get that so we multiplied this equation number 4 by the area of triangle ADC, and we got this equation number 4. Here we divide equation number 4, this equation, by the R, the radius of the circle, and we will get that the area of triangle ADC equals to CDY over 4R. Okay? But as you can see from the drawing, quadrilateral ABCD consists of 2 triangles, triangle BC and triangle ADC. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC, because of the fact that quadrilateral ABCD consists of exactly those 2 triangles. Okay, so I write it down that the area of quadrilateral ABCD equals to the area of this triangle ABC plus the area of this triangle ADC. You can see it for the drawing, this is very simple. Okay, the area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC. But we have already found out the areas of triangle ABC and triangle ADC, so we'll substitute those 2, the area of triangle ABC by the value that we found for triangle, the area of triangle ABC. We will also do the same thing for the area of triangle ADC, and we will get that we call it question number 1. The area of quadrilateral ABCD will be equal to the area of triangle ABC, we already found out that the area of triangle ABC is ABY over 4R. That's the area of triangle ADC. We've already found out that the area of triangle ADC equals to CDY over 4R. Okay? Here we take a common factor, we take AB y over 4R is a common factor of this expression. So we get that the area of quadrilateral ABCD. So I already said that we take out the common factor of y over 4R out of these expressions, and inside the brackets we will have here what is left is AB, and what is left here after we took y over 4R as a common factor is CD. So we actually found out that the area of quadrilateral ABCD equals to y over 4R times AB plus CD. Okay? So in the next step we will focus on triangle BDC. In triangle BDC, actually this triangle BDC is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times X over 4 times the area of triangle BDC. So actually, this question number 6 is the implementation of rule number 3, and this drawing, when we focus on triangle BDC, we know that triangle BDC is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle will be equal to the product of triangles BDC sides, that is to say B times C times X, B times C times X over 4 times the area of this triangle BDC. Okay, here we'll multiply equation number 3 by the area of triangle BDC, and we'll get that BCX over 4 equals to R times the area of triangle BDC. So here we will divide the equation number CX by the radius of the circle, and we will get that the area of triangle BDC equals to BCX over 4R. Okay, the area of triangle BDC, according to equation number 6, equals to BCX over 4R. So in the next step we will focus on triangle ABD, this triangle. So we know that this triangle ABD, is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle that blocks this triangle ABD, will be equal to the product of triangles ABD sides, that is to say to A times D times X, over 4 times the area of triangle ABD. I repeat again, triangle ABD is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle that blocks this triangle ABD will be equal to the product of triangles ABC, triangle ABD sides, that is to say to A times D times X. The radius of the circle that blocks triangle ABD, according to rule number 3, will be equal to the product of triangles ABD sides, that is to say to A times D times X, over 4 times the area of triangle ABD. This is according to rule number 3. Here we will multiply equation number 7 by the area of triangle ABD. And we will get that R times the area of triangle ABD equals to ADX over 4. So here we will divide equation number 7 by the radius of the circle, and we will get that the area of triangle ABD, according to equation number 7, equals to ADX over 4R. Okay? And we have already found out that the area of triangle BDC is equal to BCX over 4R. Okay? But as you can see from the drawing, the area of quadrilateral ABCD's quadrilateral consists of 2 triangles, triangle BDC and triangle ABD. Therefore, the area of quadrilateral ABCD that consists those 2 triangles will be equal to the sum of the areas of those 2 triangles. That is to say, it will be equal to the area of triangle BDC plus the area of triangle ABD. So I will write it down. That will be our second equation. The area of quadrilateral ABCD, it consists of 2 triangles, will be equal to the sum of the areas of those 2 triangles that it consists. It will be equal to the area of the first triangle that it consists, that is to say, it will be equal to the area of triangle BDC plus the area of triangle ABD, this triangle. I repeat again, triangle and quadrilateral ABCD consists of 2 triangles. Therefore, the area of quadrilateral ABCD will be equal to the sum of the areas of the 2 triangles that it consists. That is to say, it will be equal to the area of triangle BDC plus the area of triangle ABD. Very simple. You can see it easily that the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. Those two triangles that quadrilateral ABCD consists of. Okay. So the area of quadrilateral ABCD will be equal to the area of triangle BDC, but we have already found out that the area of triangle BDC equals to BCX over 4R. Plus the area of triangle ABD. But we have already found out that the area of triangle ABD equals to ADX over 4R. Okay, here we will take out x over 4R as a common factor of this expression, and we will get that the area of quadrilateral ABCD, according to the second equation, so here we take out x over 4R as a common factor of those two expressions, and inside the brackets here, after we took x over 4R as a common factor, we will have BC, and here we will have AD. So actually we found out that the area of quadrilateral ABCD equals to x over 4R times BC plus AD. But we, according to our first equation, we've already found out that the area of quadrilateral ABCD equals to y over 4R. In the brackets we have AB plus CD. Okay, so we have two different expressions for the area of quadrilateral ABCD. So in the next step we will multiply equation number 1 by equation number 2, and we'll get equation number 3. So here we'll get the area of quadrilateral ABCD squared it equals to x times y over 4R squared, and here we will get BC plus AD times AB plus CD. So equation number 3 is the multiplication of equation number 1 with equation number 2. So here we will take a root out of this equation, equation number 3, and we will get that the area of quadrilateral ABCD equals to the root of this expression. That is to say, it will be equal to the root of x times y. We have BC plus AD times AB plus CD. in the denominator we have 4r squared. We took a root out of this equation, so the root of 4r squared is 4r, because the root cancels the square, and we left only with 4r. So we actually, after we took a root out of this expression, we got this equation number 3, that the area of quadrilateral ABCD equals to this expression. Here we will multiply equation number 3 by r, this is the radius of the circle, and we will get that r times the area of quadrilateral ABCD equals to the root of xy BC plus AD times AB plus CD. Over 4. So here we will divide the equation number 3 by the area of quadrilateral ABCD, and we will get that the radius of the circle that we are looking for equals to the root of xy CD plus AD times AB plus, here it is actually BC, it is BC plus AD, so it is actually BC plus AD and here we have AB plus CD. Okay, over 4 times the area of quadrilateral ABCD. Actually, what is the value of xy? According to equation to rule number 2, xy equals to to AC plus BD. To AC plus BD, according to rule number 2. I've already implemented rule number 2 in our drawing. We've already found out that xy equals to AC plus BD. So here we will substitute xy in this equation number 3 by AC plus BD, that equals to xy. So we get that the radius of the circle equals to the root of so we'll substitute xy by AC plus BD And here we have BC plus AD and AB plus CD. All divided by 4 times the area of quadrilateral ABCD. Okay, so the only thing, we know the values of A, B, C and D, and the only thing that is left to find in this equation number 3, in order to find out the radius of the circle, is to find out the area of quadrilateral ABCD, and we already, according to rule number 3, we've already found out that the area of quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, according to rule number 1. The area of quadrilateral ABCD that is inscribed in a circle equals to this expression, when S equals to A plus B plus C plus D over 2. So S equals to A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So A plus B plus C plus D, A is 3, B is 4, C is 5, and D is 6, all divided by 2. So S will be equal to 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 6 is 18, and 18 over 2 is 9. So we found out that S equals to 9. So here we will substitute S 9, we will substitute S in this equality by 9, because S equals to 9, and we will find out that the area of quadrilateral ABCD equals to the root of S is 9 and A is 3, 9 minus 3, S minus B is 9 minus 4, S minus C is 9 minus 5, and S minus D is 9 minus 6. So the area of quadrilateral ABCD will be equal to the root of 9 minus 3 is 6, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 6 is 3. So in total we found out that the area of quadrilateral ABCD equals to 6 times 5 is 30, 30 times 4 is 120, 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 360 square units. Okay. The area of quadrilateral ABCD equals to the root of 360 square units. So we substitute the triangle ABC by this, by what the root of 316, equation number 3, and we will get that the radius of the circle, capital R, equals to the root of AC plus BD times BC plus AD times AB plus CD over the area of quadrilateral ABCD, that is the root of 360, and here we have 1 over 4. I will write down the values of A, B, C, and D. A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. And we will put the data inside equation number 3 in order to find out the radius of the circle that we are looking for. The radius will be equal to the root of AC is 3 times 5, 15, plus BD is 4 times 6 is 24, times BC is 4 times 5 is 20, plus AD is 3 times 6 is 18, times AB is 3 times 4 is 12, plus CD is 5 times 6 is 30, over 360. So the radius of the circle that we are looking for, according to question number 3, will be equal to the root of 15 plus 24 is 39, 20 plus 18 is 38, and 12 plus 30 is 42, all divided by 360. Okay, so we will make the calculations and we get that 39 times 38 times 49 over 360 equals to the area, the radius of the circle. So this expression inside the root is equals to 172.9. Is it 1 over 4, 1 over 4, and 1 over 4. So we actually found out that the radius of the circle equals to the root of 172.9 over 4 units. I will repeat again, the radius of the circle equals to the root of 172.9 over 4 units, or in terms of numbers, the radius of the circle will be equal to 3.287 units. I will repeat again. The area, the radius of this circle equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this circle, and inside this circle we have quadrilateral ABCD. Actually, quadrilateral ABCD is inscribed in this circle. We know that AB equals to 3 units, BC equals to 4 units, CD equals to 5 units, and AD equals to 6 units. So we defined AB as A, BC as B, CD as C, and AD as D. Okay? Then I presented to you 3 new rules, and we implemented those 3 new rules in our drawing in order to find out the radius of this circle. Okay? The first rule is that the area of a quadrilateral that it is inscribed in a circle equals to the root of s minus a times s minus b times s minus c times s minus d. Okay, we have this circle, and inside this circle we have this quadrilateral with, you know, that side AB equals to A units, side BC equals to B units, side CD equals to C units in its size, and side AD equals to D units in its size. So the area of quadrilateral, this quadrilateral ABCD, equals to the root of s minus a times s minus b times s minus c times s minus d. So A, B, C, and D are the lengths of these quadrilateral sides, quadrilateral A, B, C, D sides, and S equals to the sum of the quadrilateral sides, that is to say to A plus B plus C plus D over 2. Okay, so whenever we have a quadrilateral that is inscribed in a circle, like in this drawing, then the area of this quadrilateral will be equal to the root of s minus a times s minus b times s minus c times s minus d, when A, B, C, and D are the lengths of these quadrilateral sides, and S equals to A plus B plus C plus D over 2. Okay? And we also have rule number 2. According to rule number 2, if a quadrilateral is inscribed in a circle, then the product of its diagonals equals to the sum of products of its opposite sides. So if we have this quadrilateral ABCD, diagonal BD equals to y units in its size, and diagonal AC of quadrilateral ABCD equals to x units in its size. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. Quadrilateral ABCD have two opposite sides. Side BC is opposite to side AD, and side AB is opposite to side DC. Therefore, the product of the first two opposite sides, BC and AD, is B times D. And the product of the second opposite sides of quadrilateral ABCD is A times C. And according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of products of its opposite sides. That is, the first product is B times D, and the second product of its opposite sides is A times C. And the sum of the two products is B times D plus A times C. The sum of those two products, that is to say B times D plus A times C, equals to the product of its diagonals, that is to say x times y. Again, the product of its diagonals of a quadrilateral that is inscribed in a circle is x times y. And that product, x times y, equals to the sum of the products of its opposite sides. And the sum of the products of its opposite sides is BD plus AC. Okay, so x times y, the product of its diagonals, equals to the sum of the products of its opposite sides. That is to say it equals to BD plus AC. Okay? I repeat again, the product of the diagonals of a quadrilateral that it is inscribed inside the square is x times y, and this product equals to the sum of the products of its opposite sides. That is to say, it equals to BD plus AC. Okay? So whenever you have a quadrilateral that is inscribed inside in a circle, then the product of its diagonals, x times y, will be equal to the sum of the product of its opposite sides. That is to say, it will be equal to BD plus AC. Okay, that is rule number 2. And we also have rule number 3. According to rule number 3, if a triangle is inscribed in a circle, then the radius of that circle equals to the product of that triangle's sides over 4 times the area of that triangle. So, what is the meaning of rule number 3? The meaning of rule number 3 is that if we have this triangle ABC, that it is inscribed in this circle, then the radius of this circle that blocks triangle ABC will be equal to the product of triangles ABC sides, that is to say to A times B times C, over 4 times the area of that triangle ABC. Again, the radius of a circle that blocks a triangle, what is the meaning that the circle blocks the triangles? It means that all 3 vertices of a triangle lie on that circle. That is the meaning that the circle blocks a triangle. As you can see in the drawing, all 3 vertices of triangle ABC, 1, 2, 3, lie on this circle. So if this is the reality, then the radius of this circle will be equal to the product of triangles ABC sides, that is to say ABC, side AB equals to A units in its size, side BC equals to B units in its size, and side AC equals to C units in its size. So the radius of this circle that blocks triangle ABC will be equal to the product of triangles ABC sides, that is to say it will be equal to A times B times C over 4 times the area of the triangle ABC. Okay, the radius equals to the product of its sides, that is to say 2a times b times c, over 4 times the area of this triangle ABC. Okay, that is all number 3. And we actually implemented all those 3 rules in our drawing, and according to the first rule, the area of quadrilateral ABCD, this quadrilateral that is inscribed in this circle, equals to the root of s minus a times s minus b times s minus c times s minus d. A, B, C, and D are the lengths of these quadrilateral sides, and S equals to A plus B plus C plus D over 2. This is according to rule number 2, and then we implemented also rule number 2 in our drawing. According to rule number 2, if we have a quadrilateral that is inscribed in a circle like in this drawing, then the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, that is to say x times y equals to BD plus AC. Okay, x times y equals to BD plus AC according to rule number 2. And we also implemented rule number 3 in our drawing. According to rule number 3, if we have a triangle like this triangle ABC that is inscribed in a circle like this circle blocks triangle ABC, then according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times Y over 4 times the area of this triangle ABC. So the radius of the circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times Y over 4 times the area of triangle ABC. Okay, so here we multiply the equation number 3 by the area of triangle ABC, and we got this equation R times the area of triangle ABC equals to A by Y over 4. We divided equation number 3 by R, and we got that the area of triangle ABC equals to A by Y over 4R. Then we focused on triangle ADC. This triangle is inscribed in this circle, therefore according to rule number 3, the radius of this circle that blocks triangle ADC will be equal to the product of triangle ADC sides, that is to say it will be equal to D times C times Y. It will be equal to C times D times Y over 4 times the area of this triangle ADC. We multiplied equation number 4 by the area of triangle ADC, and we got this equation, and then we divided equation number 4 by the radius, and we got that the area of triangle ADC equals to CDY over 4R. Okay? And what is the area of quadrilateral ABCD? The area of quadrilateral ABCD equals to the area of triangle ABC plus the area of triangle ADC, because of the fact that quadrilateral ABCD consists of those two triangles, triangle ABC and triangle ADC. Therefore, the sum of the areas of two triangles will be equal to the area of quadrilateral ABCD. Again, the area of quadrilateral ABCD will be equal to the area of triangle ABC and to the area of triangle ADC. But we have already found out that the area of triangle ABC equals to ABY over 4R, and the area of triangle ADC equals to CDY over 4R. We took a common factor of this equation number 1, a common factor of 4y over 4R, and we got this expression that the area of triangle ABC equals to y over 4r in AB plus CD. Then we focused on triangle BDC. We focused on triangle BDC. This triangle this triangle is blocked inside this circle, is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle equals to the product of triangles BDC sides. That is to say, it equals to B times C times X over 4 times the area of triangle BDC. We multiplied equation number 6 by the area of triangle BDC. We got this expression. Then we divided equation number 3 by the radius of the circle, and we got that the area of triangle BDC equals to BCX over 4R. Then we focused on triangle ABD. This triangle ABD. Triangle ABD is inscribed in this circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABD will be equal to the product of triangles ABD sides. That is to say, it will be equal to A times D times X over 4 times the area of triangle ABD. Okay? According to rule number 3, the radius of the circle that blocks triangle ABD will be equal to ADX over 4 times the area of triangle ABD. We multiplied equation number 7 by the area of triangle ABD. Then we divided equation number 7 by the radius. And we got that the area of triangle ABD equals to ADX over 4R. And we have already found out that the area of triangle BDC equals to BCX over 4R. Okay, but we know that the area of quadrilateral ABCD equals to the area of triangle BDC plus the area of triangle ADC. Okay, the area of quadrilateral BDC equals to the area of triangle BDC plus the area of triangle ABD. We have already found out that the area of triangle BDC equals to BCX over 4R, and the area of triangle ABD equals to ADX over 4R. We took a common factor of X over 4R out of this expression, and we got that the area of triangle ABCD equals to X over 4R times BC plus AD. And we have already found out that the area of quadrilateral ABCD also equals to y over 4r times AD plus CD. We multiplied the equation number 2 by equation number 1, and we got this expression after we multiplied those two equations by each other. Then we took out a root out of this expression, and we got that the area of quadrilateral ABCD equals to this expression, and we multiplied equation number 3 by the radius. We got this expression, and then we divided equation number 3 by the area of quadrilateral ABCD, and we got the radius of the circle that we are looking for. Then we substituted xy by AC plus BD because of the fact that xy equals to AC plus BD according to rule number 2, and we substituted xy in this equation number 3 by AC plus BD, and then we found out the area of quadrilateral ABCD. The area of quadrilateral ABCD equals to this expression. We found out that S equals to 9 units, and we know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So the only thing that is left to do is to put the data inside this equality, and we found out that the area of quadrilateral ABCD equals to the root of 360 square units. So after we found out the area of quadrilateral ABCD, we put it inside this equation number 3. We substitute the area of quadrilateral ABCD by the root of 360, and here we have A, B, C, and D that we know the value of them. A equals to 3, B equals to 4, C equals to 5, and D equals to 6. And we found out that the radius of the circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of the circle equals to 3.287 units. Okay? So the area, the radius of this circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, thank you very much.